Here's our horizontal zoom function. It's very simple to zoom horizontally by just pressing the plus button. And we can go in insanely deep. And we'll show you more on that also. Zoom back out with that. You can run it zoomed out. You can run it zoomed in. Very flexible. And this area here is the number of samples. We'll just briefly mention that this is how you can kind of control the power of the scope. How many samples you want to collect for maximum samples, and it will try to capture approximately that many, but it may be somewhat less depending on the different settings that you've selected. But this is the power control here. This is like the gas pedal. Okay. Over here we've got 1 of 1. Now we've only captured one screen here, but we could have captured up to 1,000 screens and just click back through them. And remember, each one of these screens is a complete record. So again, for you Modis users, the Modis is capable of collecting only one complete record, and not 1,000 complete records. So each PicoScope screen is a complete record. We can have up to 1,000 of those. And of course, most of the time you'll get much less than that. It all depends on how you've set up your scope, how many full data records you will actually acquire and place into the waveform buffer index. Over here we have some other controls here. This is just our select items by clicking. You'll notice if we left click, you get one color of target arrows or target circles, and then if I right click, we get another. So keep in mind as we go through the movie, that's what the left click looks like, and this is what the right click looks like. But we have different things we can click on here. If we click on any particular point in the waveform, it'll give us the voltage values for that point for all of the channels that are deployed. If we right click, we can have other menu options, adding a view, turning channels on and off, and other things. In our hand view here, if we're zoomed in, let's say we're zoomed in a little bit, we want to scroll with that, we can just grab the waveform with the hand tool and move it back and forth. And of course we can also grab it down here and pan through the capture very easily. And we'll just zoom back out. And over here we have my favorite zoom tool. This is the windowed zoom feature. And what this does is it allows us to zoom into a particular area that we want to highlight or frame in the area. So let's say we wanted to take a very good close at this injector waveform. I want you to take a close look at the quality of this capture when we zoom in on it. And keep that in mind when we show you the rest of the program here. Everything's very clearly visible. If we do want to measure something too, we have color-coded cursors for voltage measurement. And if this is in the way, we can just drag it out of the way. We can put a voltage measurement there and see at what point that zener kicks in and chops off the top of that injector spike. Happens to be about 71 volts there. We can measure, let's take a second one down here. We've got 2 of these for each channel. If we want to measure time, we can come out here and frame an injector pulse width or whatever it is we want to measure, and we can see the time location for cursor 1, cursor 2. The difference between the two would be our injector pulse width, in this case 3.27 milliseconds. Make all the cursors clean up the screen, make them all go away, poof, gone. Okay? Then we want to go back up to full view. We simply press the 100% button. And these are your zoom in and out buttons. These zoom both horizontally and vertically. So if we were to use the magnification tool here, we would zoom in equally horizontally and vertically, and we can slide it both directions. And then we can also go back out the same way. Personally, I don't use those tools very often. I think you're beginning to see how easy this interface is to use, though. It is pretty intuitive, and you can get a lot done with it with virtually no preparation. However, to really make this thing reach the levels of performance it's capable of, and to be able to quickly use it efficiently in the field, it does require some study and training. And down here we have actually independent vertical zoom features for each particular channel. And we can actually expand channel A here, color-coded once again. We can expand it vertically. We can actually shrink it as well. So if you've got waveforms that are like way too big for the screen, I mean, they're way too big, they're filling up the screen, they're overlapping each other, and you really want to make it nice and neat, well, you can shrink them down and then stack them and move them around and make it all look neat, just like this is right here. We also have our Properties tab over here, and all we have to do is pull this out to monitor the scope performance. It'll give us our sample interval. In this case, it's 1.55 millionths of a second between each individual sample point. This is our sample rate per second. This is 645.2 kilosamples, or 1,000 samples per second. And this is the number of samples we're actually collecting on each of the channels that are deployed. Then there's some other data here too that's very useful. So your Properties tab can give you a thumb tab there to pull out and very quickly check whether the settings that you've chosen are actually delivering the performance that you wanted. And of course, in addition to our basic voltage probes like we have on this channel, each channel has its own set of available options. We have filter controls, we have custom probes that we can choose from the standard probes, the built-in automotive probes, or custom probes that we have created for our own use that have special settings that we particularly like. And you can make one of these probes for anything at all, any kind of probe. We've got a PV350 pressure and vacuum scaling here, so we can have our particular pressure transducer read out in pounds or inches of mercury or kilopascals or whatever it is we want. You can do any of that stuff. PicoScope does not specifically need a Pico branded probe. Like many other lab scopes out there, you have to use their accessories with their scope. Pico's not like that. It's very flexible and will allow you to configure ranges for any probe. You can find out what the voltage to units conversion might be. And you can create your own custom range for each individual probe. And of course, we have extensive training movies on how to do all that stuff, as well as custom probe sets for you to just download and import into PicoScope to give you a quick head start with those. Get some stuff into your library you can begin using immediately. We've got a custom probe deployed on channel D here, which happens to be for the secondary probe. And it gives us some choices, and as you can see, it reads out in kilovolts. The 4000 series scopes also have an input range up to plus or minus 100 volts. So we actually didn't need to deploy an attenuator to look at this injector waveform. But of course, PicoScope comes with an attenuator for each channel so that you can look at voltage spikes much higher than that when you need to. Primary voltage kicks, for example, may be over 400 volts. You can just put an attenuator on the scope and both simultaneously protect the scope from those high voltages, as well as allow you to scale on the screen for those high voltages.